So today we're going to look at a normal to a curve. And we talked about that when we were going over the homework. So the normal to a curve at a point is the line perpendicular to the tangent at that point. So if we want to write an equation for the line normal to the curve, f of x is equal to x squared minus 3x plus 4 at x equals 1. So we need to figure out what is the slope of the tangent first. So the slope of the tangent, actually let's do this in a different color. Is going to be the limit as h goes to 0 of f of 1 plus h minus f at 1 all over, and you can just write h, but I like doing this to start to remind me that I'm just finding slope. It's the change in y over the change in x. So this will be the limit as h goes to 0 of 1 plus h squared, which would be 1 plus 2h plus h squared, minus 3 times 1 plus h, that'll be minus 3, minus 3h, plus 4. All of that minus, if I substitute in 1, that's 1 minus 3 is negative 2, plus 4 is 2. All over h. So that's the limit as h goes to 0 of, let's see, got 1 minus 3 is negative 2, plus 4 is 2, minus 2. Well, those drop out. So I've got a 2h minus 3h is negative 1h. And I've got an h squared all over h. And this is what happens anytime you have any kind of a polynomial function. When you're finding the slope of the tangent line, the constants should all drop out, and you should have an expression where every term has h as a factor, so you can just do the division. So negative 1h divided by h is negative 1. H squared divided by h is h. So that's negative 1. So that means the slope of the normal will be the opposite reciprocal, which would be positive 1. And we know that the point that this goes through, the x-coordinate is 1, and we found the y-coordinate up here, f of 1 is 2. So that'd be y is equal to 2 plus 1 times x minus 1. If that's one of my quizzes or the AP exam or one of my tests, you can leave it like that. You do not need to simplify it. In fact, I wish you wouldn't. But in order to check your answers in the book, you probably need to go ahead and distribute and group like terms. That's going to be y is equal to 2 plus x minus 1. Gives you that y is equal to x plus 1. And then let me show you the graph. Oops. Clear all that stuff out. So x squared minus 3x plus 4. And then I'm going to graph both the tangent line and the normal line. So I'll graph y equals 2 minus 1 times x minus 1. And y is equal to x plus 1. Oh, let me go back to a zoom standard. So there's our parabola, there's our tangent line, and there's our normal line. And you may look at that and go, those don't look perpendicular. Well, again, it's the same problem that your calculator always has. If you're in a standard viewing window, it distorts it. So let's go to a zoom square. After we do a zoom standard, there's our parabola, tangent line, normal line, and now they do look perpendicular to one another. Any questions about that one? Okay. So this expression that we've been using, f of a plus h minus f of a over h, is the difference quotient, of f at a. It's the average rate of change of f from the point a f of a to the point a plus h f of a plus h. So graphically, it's just the slope of the secant line joining those 2 points. If we take the limit as h goes to 0 of f of a plus h minus f of a over h, like we did in the last problem, it's the limiting value of the difference quotient as the horizontal distance between the 2 points goes to 0. It gives you the instantaneous rate of change of f at x equals a. And graphically, it's the slope of the curve at x equals a, or, and we'll add this on, make that a comma, or the slope of the tangent to f at x equals a. Okay? So let's find the limit as h goes to 0 of f of t plus h minus f of t over h for the function f of t equals 3t squared minus 4 at t equals 2. Interpret the answer if f of t represents the position function of an object in feet at time t seconds. Okay. So we're going to find the limit as h goes to 0 of f of 2 plus h minus f at 2 all over h. So that's going to be the limit as h goes to 0 of, let's see, we're going to have 3 times 2 plus h squared, so that'll be 4 plus 4h plus h squared minus 4. So all that is the first part, minus f at 2. Let's see, 2 squared is 4, times 3 is 12, minus 4 is 8. All over h. So that'll be the limit as h goes to 0 of 12 plus 12h plus 4h squared minus 4 minus 8 all over h. When we're doing polynomial functions, all the constants should drop out. Let's check. 12 minus 4 is 8, minus 8 is 0, so yep. And then we have 12h plus 4h squared over h. So now we can do the division. 12h divided by h is 12. 4h squared divided by h is 4h. And again, these two functions are the same everywhere except at h is equal to 0. This one from the step above is not defined at h is equal to 0, but this one is. Specifically, it's 12. So that's the first part. Then the second part says, well, what is it that this tells us? Well, this was the change in f over the change in t. And f is the position of an object in feet. Okay. So this is the change in position. Measured in feet over the change in time measured in seconds. So, for the object, at time equals 2 seconds, what is it that we are finding? We're finding the change in position over the change in time. Yeah, actually, velocity is a better answer for that because this could have been negative. The object's velocity is 12 feet per second. So anytime you're asked to interpret something, and this is fairly common on the AP exam, you write a sentence, sometimes two, talking about what it is that's going on in the context of the problem. You always have to be talking about the problem. We're talking about an object. If they were specific about the object, you would be specific about the object. It's at a particular time. At time equals 2 seconds. And they would have accepted, if you didn't write velocity, they would have accepted that you could have also said, instead of velocity, you could have said the instantaneous rate of change in position with respect to time. Instead of saying velocity. Well, now you know why people use velocity. That's a heck of a lot quicker way to say that. But if this was something that wasn't position in time, you would have to use a phrase like that. It's the instantaneous rate of change of the number of pumpkins with respect to the number of fairy godmothers. Who knows? I used a physics one because you're more comfortable with that, but over time we're going to do more and more which aren't physics. All right, any questions about that? Cool. All right, so that's it for the lesson. Let me just say real quickly that